All right, so now we're going to look at the second worked example. Now this example, we have two wires. So there's the first wire, which is 9 meters long, and we have another wire that's 12 meters long. And these two wires are connected above at 15 meters apart from each other. So there's one point of connection for the 9-meter one, and point C is the connection point for the 12-meter wire. These two wires they intersect at that point, and so they're joined together, and they're carrying a 2-ton load that's hanging down here. All right. Now ignore this triangle over here. Just think of the load here. I'm going to construct my triangle slightly differently. So I'm not going to have it joined. All right. So you'll see that now. Okay. So what I've done to make it easy, but not so easy, and you'll see why I say that now. So I've chosen a scale. My scale is 1 centimeter equals 1 meter. All right. So the two connection points, if it's 1 centimeter equals 1 meter and the 2 points are 15 meters apart, I'm sure you'll agree with me that that means the distance on my paper will be from point A to point C will be 15 centimeters. Okay, so I just took my ruler and I measured 15 centimeters apart. Okay, then the first wire. Now the first wire I know is 9 centimeters, okay? And the reason I know that because it's 9 meters and 1 centimeter equals 1 meter. But I've got no idea which angle to draw this at. And the same for the other one, the 12 centimeter one. I've got no idea. I know it's 12 centimeters long because it's 12 meters, but I've got no idea of the angle. All right, so let me just zoom out a bit here now so you can see. And this is why I say it's an easy scale to choose, but to draw it is not as easy because it's quite big and the page is quite small. So what I do is I'm going to take my compass and I'm going to go to my ruler and I'm going to set my compass to 9 centimeters. So 9 centimeters or 90 millimeters. So there I've set it to from 0 to 9, it's 9 centimeters. Then I put it at point A. Okay, so that's where the 9-meter wire is connected. Okay, and let me see if I can get my hand out of the way here. Okay, so I have to do this left-handed. So I've connected it at point A, and I'm going to make an arc. Okay, so there's the first arc. Okay, so at point A, anywhere along that arc, how long is the wire going to be? It's going to be 9 centimeters. Okay, because my compass was set to 9 centimeters. Okay, but it still doesn't help me much. Now let's do the second one now. So now we're going to take the ruler again, and now we're going to set it to 12 centimeters. So we're going to go to point 0, and we're going to go to 12, and now my compass is set approximately to 12 centimeters. Okay, and I'm going to connect it I'm going to put the point on point C, and I'm going to draw another arc. So another arc. So big arc, and there I've drawn that. Okay, so anyway from point C along this arc now, it's going to be 12 centimeters. Okay, now what you need to notice now is that these two arcs intersect. And what we need to do now is from point A to where they intersect, I'm going to draw a line. So from point A to where they intersect, there's my first line. And I'm sure you'll agree with me that is 9 centimeters long. All right. And then the second one, I'm going to also from point C now, I'm going to join to where these two arcs connect. So from point C to where they two connect. And you're going to see that that's 12 centimeters, which equals 12 meters. And this one is going to be 9 centimeters, which equals to 9 meters. So there I've drawn it. And all I need to do now is put the load in. Let me do that in red. And there is my 2-ton load. Okay. Now I can actually draw my force triangle from this. And remember, now we need to, the only one we know there's a load in, so we don't know the loads in these two wires. We only know the load here. So what I need to do is I need to take this one that I know the load in, and I need to draw that to scale. So I go down here on the page, and I'm going to now I have to choose a scale, and 2 tons. I could say let's see, a 1 centimeter equals 1 ton. I could say that, but then you'll see when I draw it to scale, it's going to be quite small. It's only going to be 1 ton, 2 tons. So I'm going to have this really small triangle, and that's not so great. Okay, I could say 2 centimeters equals 1 ton, and that'll be a bit better because now that's 2 centimeters for 1 ton and another 2 centimeters for the next ton. Okay, so that would be a 4 centimeter line. Okay, and that's a bit more accurate. Okay, because I'll be able to see those millimeters a bit better. Okay, so basically, my scale, you can either say it's 2 centimeters equals 1 ton, or I can say 20 millimeters equals 1 ton. Okay, so that's what I'm going to use. 20 millimeters equals 1 ton. And then I get, so over here now, it's 40 millimeters equals 2 tons. Okay, so there I've drawn that to scale. So that line I've drawn to scale over here now. Now, what do I need to do? So I need to just go a bit more out. That's why I say this is drawing the triangle this big. It's not that great. All right. So now what do I need to do? So I've done that one just like in the previous example. So there's the 2 ton to scale, and then I'm going to go in order. So firstly, I'm going to go to this line, the 12, and then I'm going to go to the 9. And I'm going to transfer these lines down in parallel. So you're going to see they're going to be different length, but I'm just going to transfer them down in parallel. So what I do is I take my ruler and I take my triangle and I line it up. So you can see it's lined up there now to that first wire, and anywhere I move this thing now, it's going to be in parallel to that first line. So let's do that. So it's lined up, and I'm going to move it down, and I'm going to put it over here, and I'm going to draw a line. And I don't know how long the line should be, so I'm just going to draw a long faint line there. And then that is that first wire. Now the next one, which is the 9 meter one, let's do that one now. So again, I'm going to make it in parallel like that, line it up, and let me go a bit down more. So I've lined it up, you see there, and anywhere I move this across now, it's going to be in parallel. So there we go. And I make another line down there. And you can see now that these 2 lines, they intersect over there. So let me zoom in on that now. Let's go down here. Okay. So now what I need to do is I'm going to just draw them a bit darker so you can see. So this one here represents the 9 meter wire, and this one represents the 12 meter wire. Okay, so then I need to measure these. So let's see. Okay, so I'm going to take my ruler and I'm going to measure. So what do I get here? So, okay, so it's not going to be exactly the same for everybody, but you must try and do this as accurately as possible. So over here, I've measured about 20, let's say 24 millimeters. Okay, so 24 millimeters. Okay, so that's for the first one. And for the second one, I've measured it's about 36 millimeters. Okay, but that is not the force in the wire now. So what we need to do to get the force is we need to divide it by the scale. Okay, so 36 millimeters divided by 20 millimeters. You see why I've chosen it in millimeters? So that it makes it a lot easier. Okay, and then over here, this one, 24 millimeters divided by the scale, 20 millimeters. And let's see what we get. So we've got 24 divided by 20, and we're going to get 1,2 tons of force. Okay, for that one. And for this one, 36 divided by 20, and we're going to get 1,8 tons of force. Okay, so that's how you do it. Now, I'm going to just quickly show you now that the same thing can be done, but drawing this triangle up top here smaller. Okay. All right, so now I've drawn the same, or done the same problem, but as you can see, my triangle is smaller. So previously I said that the two from point A to point C was 15 centimeters apart because it's 15 meters. But I just want you to see that even if I change the size of the triangle, it doesn't affect the answer. So okay, my accuracy, I did this one a lot more accurately, but it doesn't affect the answer at all. So remember, the lines that we transfer down, the only thing they need to be is parallel to these lines. Okay, so when I make my force triangle at the bottom, I just have to make sure that the two lines are in parallel. And if I do that, and I draw the one force or the one vector to scale that I know the force in it, then it will work out the same. So I just want to show this to you. So like I said, last time this was 15 centimeters long, but now you can see I've drawn it 7,5 centimeters equals 15 meters. So that means over here now, my scale is actually half a centimeter, or yeah, half a centimeter equals 1 meter. Okay, so you can draw this to any scale, this part, and it won't matter. So you can see now, if that's the case, instead of 15 centimeters, it's 7,5 centimeters. And this one here, instead of it being 12 centimeters, now it's 6 centimeters. And this one here, instead of it being 9 centimeters, it's now 4.5 centimeters. And you can see the same thing I did. So I set my compass to 4.5 on my ruler, and I made the arc, just like last time. I made the arc, and then I set it to 6 centimeters instead of 12 centimeters, and I made the arc. So you can see that I made the arc, and you can see where the two intersect. See, there's the one arc and the other arc, and they intersect at that point there. I join the line, so from that point to C and from that point to A, and there I've got my triangle, and I know the angles now. I draw my force down, and then all I need to do is I go down to the bottom here, and I'm going to, firstly, I'm going to draw the 2-ton force. I'm going to draw it to some scale. Again, I've done it, what is this now? Let's see, 1 ton equals 20 millimeters. Yeah, there, I've written it there. 1 ton equals 20 millimeters. So that's 40 millimeters long. And you can see I've done this in color now, so you can see. Let me just go a bit more out. Okay, so you can see here the red, the 9-meter one, I've transferred down in parallel. So you can see it's just transferred it down in parallel like that. And the blue one, which is the 12-meter one, I've transferred it down to that point there. All right. And again, I measured it. So I measured 24 millimeters and I measured 32 millimeters. And all I needed to do was to get the force in this one. I said 32 divided by 20, which is a scale, and I get 1.6 tons of force. And for this one, 24 millimeters divided by 20, and I get 1,2 meters, or 1,2 tons of force. So just to show you that it doesn't matter this triangle, it doesn't matter what scale I use. What does matter is that when I transfer it down, it's in parallel. So I hope that helps.